HOD Professor A.K. Chatterjee sir, my seminar guide Dr. O.S. Prajapati sir, and my seminar coordinator Sri D.P. Sharma sir, and all of the faculty members, examiners, and the batchmates. I am Samridh pursuing my Bachelor's of Technology from University Department of Mechanical Engineering, Rajasthan Technical University, Kota, Rajasthan. Today I am going to present the seminar on the topic Advancements in Composite Manufacturing Techniques, which is guided by Dr. O.S. Prajapati sir and coordinated by Sri D.P. Sharma sir. The things that we will learn in this seminar are Introduction to Composites, the basic and advancements in composite manufacturing techniques, the applications, conclusions, and also the references to material reviews will be given at the last pages. First, we will understand that what is composite. A composite is basically a material which is a combination of two or more materials to form a single material, and the resulting material should have the physical properties significantly different from the constituent materials. Example: cement and steel rods combine together to form reinforced concrete cement. The cement cannot withstand high tension, but it is very good in compressive properties. On the other hand, steel rods have very good tensile strength, but has a tendency to buckle when compressive load is applied. But when they are combined together, the reinforced concrete cement is formed, which has very good tensile, compressive, and bending strength. The constituent metals of a composite is further divided into categories. One is fiber, and the other metal is known as matrix. The job of the fiber in a composite is to provide strength to the composite, while the matrix supports the fiber and makes sure that the load is properly divided among the fibers. And also, it helps to protect the fibers by various environmental factors like corrosion or degradation. Generally, in a composite, the volume fraction of the fiber is less than the volume fraction of the matrix, and the fiber and the matrix needs to be properly stick together for the proper working of the composite without any failure. There are certain advantages of using composite material over the traditional materials, and that is, we will get higher strength, stiffness, and toughness even in the lighter weight of the material. Also, the composites are highly customizable according to the needs. For example, you can make carbon fiber composite for a lightweight use in the aerospace industry. The composites are even resistant to the various environmental factors. For example, a normal iron can be corroded with the moisture present in the atmosphere, but if you coat it with a silicone layer, then it will not be going to be corroded so easily. Now we will see the basics and advancements in composite manufacturing techniques. So here is the history of composite manufacturing techniques during the early ages. In 3500 BC, people used to make the mask of linen coated with a layer of plaster of Paris for the dead persons as their memory. Later in the 1500 BC, the difficult to use long bows were converted into short bows by making them with the composite materials. The wood and the horn of the animals were stick together with the use of sticky substance called sinew. In the 1800 AD, natural resin started to be extracted from the plants and animals and began to use as a matrix material for sticking fibers together. In the 1900 AD, an artificial resin started to be made like plastic polymer cables. During the World War II, fiberglass was used for making lighter war machines like planes and different types of machines for the use in the battlegrounds, as they were lighter and easy to handle than the machine made from the traditional materials. And in about 1980, we saw the use of RCC in the infrastructure. The RCC was the first concrete cement where the use of reinforcement of steel rods in the cement as a matrix material. And then the modern era started the manufacturing of composite with various design factors and physical properties. Some of the methods of manufacturing the composite traditionally were all done by hands, whether it is casting, mixing, or gluing materials one over the other. The advanced composite manufacturing technology that are used nowadays to manufacture composites are of different types and offer a wide range of design possibilities according to the specifications needed. Some of the advanced composite manufacturing techniques are nano-composite manufacturing technique, automated filament binding, pultrusion, and additive manufacturing. And we will discuss about these in the upcoming slides. Nano-composite manufacturing techniques. In this technology, we use microfibers so that we can achieve a very high surface to volume ratio in the composite. And also the aspect ratio of the reinforcement fibers are very high. And due to these properties, the bonding of the fiber and the matrix together is very high, and that shows in the strength of the composite. Also, sometimes there is a use of carbon nanotube and electrospun fibers as nanoparticles in the nanocomposite. So to increase the strength of the final composite by having a very high area of interface between the matrix and the fiber. The picture given below shows it. Now, the methods that are commonly used for nanocomposite manufacturing technology are in situ polymerization, solvent-assisted method, and melt homogenization. The basic aim is to crush the particles to up to 100 nanometer to make it nanoparticle before mixing it with the matrix. In situ polymerization, the step-by-step method is followed, which results in the formation of hybrid between polymer molecules and nanoparticles. In melt homogenization, heat treatment is done by putting the sample into the furnace at high temperature below the solid temperature of the alloy for an extended period of time to make nanoparticles. The figure shows the basic steps, that is, atomization of the particle at nano level, then adding the hardener, the ultrasonic mixing, then it is cooled at the room temperature, then epoxy is added, then it is mixed, and then molded into the desired shape. The second advanced process is the tape laying process, which includes the use of wide pre-binder infused tapes. The tapes are made up of fiber, which are applied on the required surface to provide strength. The tape already contains a thin layer of binder material that sticks with the surface after cooling. To make the pre-binder material of the tape fuse with the surface, some heat and pressure is applied. It is very fast and effective process to provide strength in the material. It is capable of achieving a very high production rate. Filament binding process. In this process, filament is binded at a high tension of a roller to make a part of very good strength. Due to the presence of continuous fibers in the filament, it provides good strength. The filament is made up of a combination of long fibers that are stick together after getting soaked in resin. The fibers are itself composed from the set of strands of long fibers. The making of the filament from the fiber strands is also a part of the filament binding process. Due to the use of long fibers in the production process, the strength amount that it provides to the final product is very high. So from this manufacturing technique, mainly cylindrical parts are produced, like pressure vessels for keeping the gases at very high pressure. Moreover, other open and closed cylindrical parts can also be manufactured from this process. Now we will see the pultrusion process. In this process, a series of fiber spools are kept in a rack, are engaged to label fibers in the form of threads. And later on, these threads of fiber are passed through a die of having many holes after the application of resin material. The holes are arranged in the particular cross-section which is required according to the cross-section of the product. In this process, the parts of the constant cross-section is produced, such as square or circular tubes. Also, instead of using threads of fibers, we can use the vocal fiber sheets and apply resin on it and pass it through the die of the required cross-section to form the final product. In this process, heat and pressure is applied when the material is in the die, because it is required that the sheet of the threads of the fiber should be hardened properly before coming out of the die to avoid any deformation or irregularities. The figure shows the pultrusion process in which many fibers are stitched together to form a particular cross-sectional product. Additive manufacturing. It is the 3D printing process by which parts made of a composite material can easily be manufactured. It has a very faster production if we are producing only one. Complex shapes can easily be manufactured by this process just by making the design of the particular required complex shape on the computer as a CAD. In this process, pool of filament made of a composite material is heated to a particular temperature to make it flow and then is built into the desired shape. The process uses the manufacturing of parts step by step and layer by layer from bottom to upwards till the completion of the product. Now coming to the application of the composite manufacturing techniques. There are many industries that are using composites or are intended to use composite in the future. So they must choose the composite manufacturing techniques according to their design requirements and the requirements of the physical properties of the required product. For example, for a chemical industry that uses the pressure vessels for strong chemicals or other gases product, filament binding process is used to manufacture the seal because the presence of the long fiber in the filament, this technique provides high strength to the pressure vessel or cylinder for the strength of high pressure chemicals and gases. In the aircraft industry, for making the light and strong wings of the aircraft, automatic tape laying process is used. Nanomaterial manufacturing methods are used to make fuel cells, batteries, sensors, and optics, as they inherit the properties of the constituent materials without disturbing it to a greater extent. Additive manufacturing is commonly used to make prototypes because it's very easy to manufacture new parts only by design with the help of 3D printing, even if the product or part is complex. Now coming to the conclusions. We can conclude from this seminar that the composite have many advantages over conventional materials. They offer flexibility in design and various manufacturing techniques to choose. Manufacturing techniques for a composite should be chosen according to the proper design requirements, the strength requirement, the stiffness and toughness requirement, and various environmental factors such as reaction with the environment and the working conditions like temperature and pressure. That was all about my presentation. Thanks for listening, and any question if you want to ask.
Yes. Tell me one of the industry where the use of composite can be adopted in the future.
The application which I'm thinking about was the smartphone industry. The smartphone nowadays are becoming heavy, so I guess they should try to make the smartphone lighter and stronger composite materials instead of using glass, aluminum, or steel. That of course Apple and other brands are using.